Good afternoon, everyone. Here on the West Coast of the United States, good evening to the East Coast, and good morning to APJ. Welcome to Data and AI Summit, where the theme this year is The Future is Open. My name is Richard Garris. I'm an AVP at Field Engineering. And today I'm going to talk about architecting Agile applications at scale. So just a brief agenda, a little bit about myself, a little bit about the world's most valuable companies and how those companies became the most valuable. We're going to talk a little about software development and the history of different methodologies from waterfall to Agile, as well as talk about the difference between traditional data platforms and modern data platforms. And finally, I'm going to do a summary. Also, at the very end, there's going to be a survey for this talk, and I'm looking forward to your feedback. So a little about me. So I'm a proud Buckeye. I graduated from Ohio State. I also got my master's degree at Carnegie Mellon. My undergraduate degree was in MIS and accounting. And then I got a software management degree part-time at Carnegie Mellon University. I spent the better part of 2 decades in the data space, starting all the way back when we had IMS databases, information management system databases on the IBM mainframe, old hierarchical systems. I worked through our phase with RDMSs with Oracle and SQL servers, our main data platforms. And most recently, I've been working in big data. I was working on Hadoop and Spark. I've worked for 3 years as an independent consultant, 5 years in data management within PricewaterhouseCoopers, which is one of the premier consulting companies today, as well as 3.5 years at Google on their data team, and the last 6 years as a AVP at Databricks, where I'm working with our customers to really transform their businesses around data. I'm also a certified Scrum Master. I got certified pretty early, which will be an interesting fact when we get later on into the talk. I've done several other talks at both Data and AI Summit, as well as other popular areas in terms of Agile, Spark, and model development with Data Science Central. I did a talk on ETL 2.0 for MSDN Channel 9 with Microsoft. These links will be available to you when I pass on these slides after the talk. And if you'd like to look at my other talks, it's also on my LinkedIn page. Just look for Richard Garris. So if we look at the last 28 years, and it doesn't even feel that long, at least to me, the top companies in the world has changed. So back in 1993, the top companies in the world were iconic brands like General Electric, ExxonMobil, Walmart, Coca-Cola, Merck, and they really dominated the Fortune 10 companies in the world. But in the last 28 years, you can see the shift. We've gone from these very iconic brand name companies to mostly being technology companies. So the top 5 on the list here are Apple, Microsoft, Amazon, Alphabet, or Google, as well as Facebook. So you can see that this shift over that period of time. And so the question is, though, these top companies, what are they doing differently? If you look at Facebook, Apple, Amazon, Google, Microsoft, often called FANG, FANG minus Netflix, what are they doing differently that really allow them to be as competitive as they are? So a lot of people have talked about this, and there's been many discussions on Medium as well as other publications. Is the reason why these companies are very successful because they have lots of data. I would say from my view, doing this for 2 decades, not really. So at one point in time, the FANG companies may have had some very unique data sets, whether you're Facebook and having 2.7 billion user profiles, if you're Google having search results or information from YouTube. But a number of other Fortune 500 companies, commercial market companies, as well as other digital natives and our public sector, state and local governments have a lot of data too. Is it because they have better artificial intelligence, deep learning, ML algorithms? Again, not really. At one point in time, they did. They had a lot of proprietary IP for how they could do more advanced analytics. But today, a lot of that is available in open source. So Google published TensorFlow not too long ago. Facebook's claim to fame is PyTorch. Amazon is MXNet. Microsoft is like GBM. A lot of that is available in open source. And a number of the other algorithms are also available in research papers today. So that's also not quite the case. Or is it because they have better data processing? Again, not really. I mean, at one point, Google, Amazon, Microsoft, Facebook, Apple all had the best infrastructure in the world, custom built servers, custom built hardware. But today, because of the advantages that you get from public cloud, a lot of those technologies are available to anyone that wants access to that and available on demand. There's also a number of open source and commercial softwares available to anyone who wants to process big data at scale. So again, that's all available to most companies. So why are these companies doing as well as they are? So I'm going to do a quick poll. Should have popped up on your screen. Any guess what these numbers are? 20,000, 36,000, 60,000, 90,000. So I'll wait for a few seconds for people to answer the poll question. These are the number of engineers that each of these companies employ. So I did not use any public information for this. I only use public information, no proprietary, no confidential data. I derived this from looking at public job postings, Glassdoor, looking at R&D spend as a percentage of total salary spent on FTEs. And so these are all best guess estimates because these companies keep the number of engineers they actually hire pretty close to the vest. But as a percentage, they hire more engineers than your average organization out there. And that really what distinguishes them from the rest of the Fortune 500 organizations that are out there and attending the summit today. So what do all these engineers that these companies have hired, what do they bring to the modern enterprise? They bring Agile. So one of the things that we've seen with software development is it is a very, it's a profession that requires a lot of adaptation to change, hence why the birth of Agile development over 20 years ago now. It's really the premier way that people manage the life cycle of software. So you can see here in this quick diagram, it starts with design, develop, test, deploy, operate, and support, and it's a continuously improving cycle for how you develop and maintain software. And I'll get to a little more about Agile in the future slides, but a lot of this came out of actually Japan around Kanban and specifically Toyota to improve the manufacturing process so they can actually make more competitive cars. And based on learning and retrospectives, continuously improve that process to make the best cars they could, the highest quality, while also reducing the overall cost. So I follow a number of different venture partners within Silicon Valley. I myself live in San Jose. One of those is Jack Bunkowski. He's part of the US Venture Partners. So just more of a thought-provoking question. It's going to be rhetorical, but the question is, do startups actually change the world? So I'd argue they do, but they don't, because startups don't change the world. They actually adapt to the world faster than everyone else. What you'll find is that everyone has some great ideas or some great theorems, some great hypotheses on what could be a great way to solve a new problem that comes out. But really what distinguishes these top 5 iconic really software companies from others is they're able to adapt a little faster than everyone else. As a couple of examples, Amazon in the mid 2000s, they were still relatively small, going from a bookseller to being a general product seller. What really allowed them to take off was the idea of Amazon Prime and eliminating shipping fees. History could have been very different. They learned a lot based on looking at the data, looking at how they did their e-commerce experience for their customers. One of the experiments they wanted to run is, if we get rid of shipping fees, can we really increase overall adoption of e-commerce and Amazon? And they did. If they didn't do that, they didn't adapt to what the market wanted, history could have been different. I mean, eBay, Overstock, or Walmart, when we were traditional players, could have dominated e-commerce. But with that one change, Amazon really transformed their business. I see the same thing with Google. So I used to work there, but this is public information. Google is very relentless about rewriting backend services to adapt to the needs of their users. One of those examples is their search engine. And the version of search you use today is very different than the version in 1998. It's probably somewhere between 7th and 8th version of that experience. And as a company, you want to continuously adapt the user experience so you're continuing to be competitive and also adapting to what your customers need. But what does that have to do with data applications, right? So really what these companies have done is really brought Agile to data applications. I'm going to cover that in this talk. So some of these are based on the technologies these companies have championed, including things like MapReduce from the Google paper, Google File System, GFS, Amazon, and then before that Yahoo and Facebook have championed a lot of Hadoop. And the reason why they champion these types of technologies is because they do allow for more of an agile data application, and it follows the standard software development principles, things like being testable, open source, not using proprietary software languages, and allows these companies to actually scale their data pipelines to meet the needs of their businesses in a very agile way. If I rewind back to when I was, in my undergraduate and look at like the 90s, what was common in the 90s in terms of software development was really the idea of waterfall. Waterfall is very much one stage following the other. It's very hard to accommodate change, and change is very expensive because it assumes everything is very single-threaded. You go from concept and requirements, analysis, design, development and implementation, test and QA, and finally deploy and maintain. And at any point along this step function, there is a change or change in requirements. You have to go all the way back to the beginning and start over again. So it's very hard to accommodate change in the waterfall methodology. And this is how software is really built. It was really built with this type of framework. At the same time, traditionally data architectures came out with Bill Inman and the idea of having the enterprise data warehouse. It worked really well in the 90s, early 2000s because it worked for the time and the era. Most operational systems had very little data, mostly structured, small data volumes. There is GUI tools to do ETL, like Informatica, Ab Initio, Oracle Data Integrator, or you could use the native capabilities in the data warehouse or the database, things like PL SQL, store procedures, T-SQL, et cetera. You process data using those types of ETLs. You store all your data in the data warehouse itself using what's called staging tables, which are often unmanaged and sometimes would be deleted because to save cost. And the single source of truth was the monolithic data warehouse, where everything was, predefined schemas, is all very predictable. And most of the EWs were sold as expensive appliances. So it was locked into a proprietary format that combined both compute and storage. And the only way to scale this out was to either buy more appliances, buy more Teradata, buy more Oracle, buy more IBM DB2, or to buy more expensive versions like Oracle RAC and other ways to do better performance. But these data warehouses also have minimal support for arbitrary files, as well as semi-structured, unstructured, or streaming sources. It was also very inflexible because to add a single column to, or let's say a report, or if you're a data scientist building a model, it can take up to 6 months because it's built for waterfall. So you'd have to go back to the original source system, pull it in, do ETL, put in the staging area, put in the data warehouse, and then it would take 6 months to add to a report, which doesn't really work when you're thinking about adapting to new business needs. And it did work well for human intelligence, things like accounting and finance and static reports, as well as dashboards, but didn't really work well for AI or ML because most of those AI and ML tools are really querying like the static data sets available in your warehouse, and you couldn't get to more data that can actually make your model actually better. In general, like this time frame, because I was a former Oracle DBA, most of the users of this type of tool were DBAs, ETL designers, BI analysts, and there's no real data engineers or data scientists at this time. I can't tell you how many hours I spent, tuning an Oracle database, going back and looking at all the different queries and the query planners. It was all a lot of effort for a very hard-coded, hard-to-manage system. So fast forward a little bit, let's go back to kind of our software development discussion. So around the mid-2000s, I got my Certified Scrum Master certification, and I heard about the Agile Manifesto, which was published in 2001. The Agile Manifesto was really a rejection of the waterfall methodology. It was a pushback against all the paperwork and the bureaucratic processes required to build software. So very early versions of Agile were what's called Scrum, which is depicted on the screen here, as well as XP, Extreme Programming. And it worked really well for small self-managed teams, and it kind of took away a lot of the heavy approval and the heaviness of the waterfall methodology. But it didn't scale well to larger teams and the needs of larger enterprises because it lacked some of the discipline of waterfall. The good parts about this, though, if you look at the diagram here, is it created the idea of iterations or sprints, where every 2 weeks, you're looking at what are the user requirements, what are the things the customer are doing, what are the stories, being able to do some implementation work, do a daily scrum meeting to see how you did, do retrospectives to evaluate how well you did, and then rinse and repeat. So with this type of methodology, you can basically incorporate, or you can incorporate change as part of the process. And it also incorporates the idea that everything can be an experiment. You can do hypotheses. And as you learn more through your process of building whatever project or software you're doing, you can actually accommodate those changes. So around the same time, we also had the idea of the open data lake, or Hadoop. So the open data lake was a little bit like pure Agile, in that it gave a lot more flexibility to how people manage data as well as data applications. So this type of environment, Hadoop supported new data sources like web scale data, SaaS sources like Salesforce, as well as the old operational systems of structured data. But it also supported semi-structured, so you could load logs, JSON, unstructured data like images and audio, because everything is just a file that lands in HDFS. Going to handle the high volume and high velocity data, also could handle some level of streaming data. And again, HDFS was great because it was built on commodity servers, so it wasn't locked in proprietary file systems like SANs or like Flash and storage, et cetera. And because of that, it was beefy servers, but relatively less expensive than the expensive appliances from data warehouses. Applications can be written and deployed inside of Hadoop using yet another resource negotiator or Yarn, and can be written in open source languages like Java, Scala, or it can be written in Hive, which is the SQL engine for Hadoop, or in more custom scripting languages like Pig and Mahout for machine learning. The commodity servers allowed you to scale this out, so you got better performance because you could run things at scale across a number of different computers, a number of different cores and memory and servers. So initially, it was cheaper to get a better compute because you are using commodity servers and because you can scale it out. But because compute and storage were paired together, you often had to provision enough capacity to handle the max amount of storage, max amount of compute, and you couldn't really pay for what you used. You had to, again, if you need more storage, you had to buy more servers, or if you just need more compute because you have some pretty complicated processing to run, you'd also again have to buy more compute. The forms actually ended up being a little more of a mixed bag. So it allowed scale out, but it was very hard to tune Hadoop and Yarn. So with Yarn, you had to, it's very much a 1.0 type experience with distributed compute. You had to specify the amount of memory, number of cores for each job, which is always really hard to estimate. And then you had the various different SQL engines on Hadoop, each of those trying to improve incrementally the performance of the query engine. So things like Impala, Hive variants like Hive LAP. And every time you add a new engine, yes, it might have been faster, but it was also hard to tune and hard to scale that out. Really, the hallmark of Hadoop was the idea of schema on read versus schema on write, which created a ton of agility. But because of the lack of schema enforcement and reliability data became an issue, hence the data lake often became a data swamp because you didn't have a source of truth in terms of the schema. Hence, you'd have just everything as a file, and it's hard to reason about what is actually in your data lake. It also still has some monolithic attributes. Because you actually deploy these data applications into Hadoop and you compared your compute and storage, everything had to be upgraded at the same time. So if you're using a certain version of Python, like Python 2, going to Python 3, you have to upgrade every application that uses Python. Or if you're upgrading from Hadoop 2.1 to 2.2, again, you have to upgrade all the applications at the same time. So it's very hard to create kind of agile teams that are self-managed if everything has to be done in a more of a waterfall method with all these different teams working together. And lastly, I think this is also one of the hardest parts of Hadoop. It required very specialized people to manage and develop on Hadoop. You need special admins, trained developers. They had to use different frameworks, MapReduce, Tez, Hive, different SQL engines on Hadoop, Spark, Flink, Storm. It was very hard to find general software developers or general data practitioners that could actually use Hadoop without necessarily needing this special training. And lastly, analysts and issues did use Hadoop, but didn't concern themselves with the infrastructure because they were shielded away from a lot of this complexity, but ultimately would fall back to the EDW whenever they had performance challenges or data wasn't available or they couldn't find the data. And so ultimately, the goal and promise of Hadoop was to offload or even replace EDW, but that didn't actually happen over the course of time. So again, going back to our software development, what happened in the mid 2000s to just about today is the idea of modern Agile. So modern Agile is very much a hybrid. So it took advantage of some of the information we've learned from Waterfall, as well as what we do in Agile, to put together a more of a modern way to think about software development. So it incorporated a lot of different things from Waterfall, things like how we measure value, how do we think about governance, risk management, security, how are we doing executive steering committees, and making sure stakeholders are involved, but still keeping the spirit of the idea that you have sprints and iterations and change as part of the process. So you're trying to combine the best, both the best of both worlds, both Waterfall as well as Agile together, and creating a single hybrid that can do both of those things. My favorite is DAD, or Disciplined Agile Delivery. There's also another one called SAFE, or Scaled Agile Framework. But these are both now well-defined frameworks for doing kind of modern Agile. So the next hybrid that is coming just as we speak is the idea of a lakehouse platform. And again, it is a hybrid. A lakehouse is a portmanteau of a data lake and a data warehouse. We've seen this in the late 2018, 2019 timeframe to now 2020s and beyond. And the idea here is that you're really combining the best of the data lake, when we learned from the 1.0 Hadoop, with the data warehouse. Again, so this lakehouse supports old and new data sources. It supports the scalability of the cloud as well as multi-cloud. So any cloud you want, or as well as private cloud if you choose to do something more on-premise. It supports structured tables. So it supports structured data, semi-structured data, logs, JSON, audio, images, live data through streaming. And all your data is stored in an open storage format. And one of the key tenets of this platform is it separates out compute from storage. So you have a place where you can store data in an open format. It's reliable, also infinitely scalable if you take advantage of object stores like S3, ADLS, Google Compute. But most importantly, what distinguishes this from your general Hadoop 1.0 data lake, it has a data management layer for reliability as well as schema enforcement. The most common of those on the market in open source is Delta Lake, Iceberg, Hoodie, to some degree Hive Acid, because it gives you transactional guarantees and also a way to make sure that the data you put into your lakehouse is good quality data so that your downstream users can actually take advantage of that for reporting, analytics, data engineering, as well as data science. It also supports the idea of having multiple layers. So this is common, similar to the staging table architecture you saw in the data warehouse. So you have a landing zone or bronze, you have a silver for your refined data where you cleaned up and moved duplicates and got rid of your bad data. And lastly, you have your gold layer. I'm jokingly calling it Dogecoin, because right now, Dogecoin is actually more expensive than gold for all your business level aggregates for your final reporting layer. Now, this architecture isn't something where Databricks invented this or a vendor put it together. This is really what we see from other tech forward companies like a Netflix, that how they think about architecting their data lake. And this is where you actually build Agile data applications into a platform that separates out the compute and code from the actual storage layer. So you can have different data science notebooks, you can have different data engineering projects, you use MLflow, for example, to orchestrate and manage the lifecycle of your models, but it sits outside of the storage layer, it sits outside of the platform, so you can actually have agility and have each team have their own data projects that don't collide with each other. And then you can do all kinds of analytics with this lakehouse platform, everything from doing internal applications, doing dashboards and reports for internal usage, using whatever BI tool you use. You can do external customer-facing applications, end-to-end model lifecycle, recommendation systems, customer-facing applications. And this is a difference from the Hadoop, where you're really doing internal analytics. Here, a number of our customers at Databricks, as well as other customers that use these lakehouse platforms, can build the end-to-end lifecycle for customers and actually deliver value directly to them. And lastly, you can move your data from your lakehouse to your downstream systems as needed for specialized data storage, whether you're looking at graph databases like Neo4j, NoSQL databases for real-time access, or looking at EDWs if you need an EDW for doing other reporting, and using EDW for just your final reporting layer. So I'm running a little short on time, but I'll go through a couple of other slides. So one, this is great for modern data personas. So data scientists want an environment where they can be very experimentative, because data science is a science. It's going to take constant evolution, experiments, and hypothesis to learn what is the best model to use. get data scientists off their laptops and into an environment where they can access it in a secure way. It's also great for engineers. Data engineers are developers. They want to write code in standard programming languages like Java, Scala, and Python, and not in proprietary software features or ETL. It also gives them the ability to write high quality production code that is testable, reusable, and modular, and can be continuously integrated and deployed into production so they can actually really evaluate how well the pipeline works in a prod environment. And lastly, for data analysts, it gives them more access to data quicker, so they can actually get quicker access to data as it's produced in the transactional systems. And they can even use a little bit of Python or R, a lightweight for advanced analytics, and get some way from downloading data from the data warehouse into Excel or downloading into using a Jupyter notebook. And they can do the analysis in an environment that gives them that flexibility. So a little bit about data mesh, and I'm going to go a little bit faster here. Data mesh is an architectural pattern introduced by Jamak of ThoughtWorks, and it's talking about how you can think about moving beyond a monolithic data lake to a series of self-managed teams that actually manage data as a product. So again, data is a business asset, but if data just sits in a lake or sits in a data warehouse and doesn't get used, it's not being monetized. So by actually dividing up data access and data control to different self-managed teams, you can actually be much more agile about how you use data as an asset and produce value out of it. But also, you want to have governance and standards that are actually centralized, so it allows for scalable interoperability and data sharing. And this whole notion of data mesh sounds a lot like the hybrid that Agile and the lakehouse approach provides. So again, I work at Databricks, but I also am a firm believer in best technology should win. So I have a slide here talking a little bit about the differences between, when you think about lakehouses, where you want to look at Databricks, what we provide out of the box. I won't read every bullet point, but gives you a sense of what Databricks provides for a lakehouse. You can look at what the cloud providers provide out of the box. So whether it's a combination of EMR, HCI, Dataproc, and different query engines, or you can do it yourself. And there's advantages and disadvantages of each of these. And so I would look at these different options. You think about what is the best technology to use to support your lakehouse framework and your paradigm. And so in summary, if you're thinking about Agile data applications, you really don't want to put your data into a data warehouse or a first generation data lake, because you often have to pay more for storage, over-provisioning your compute. Reworking change is very expensive. It's not really built for agility. Data is monolithic and hard to support the notion of data mesh as well as self-managed data domains. But with an Agile data application in a lakehouse, you only pay for what you use, should lower your overall total cost of ownership. Agility and change is part of the data application lifecycle, so you can easily adapt to new use cases, new projects, new products that you're trying to launch within your business. And it easily supports the idea of one data application per project, team, or domain, and easily supports the idea of the data mesh paradigm. Thank you to everyone who attending Data and AI Summit virtually this year. Your feedback is important to us, so please review the session and let us know how any questions you have, as well as any feedback you have. Thank you much.